Hi everyone, welcome to the video. Today we are going to solve delete without head pointer. In this question we are given a linked list, okay, along with a delete node, okay. And we have to remove this del node value from the linked list. Cool. But there are some conditions. There are conditions to make to confuse you, but this is pretty straightforward and easy question. I'll tell you how. See, by deleting the node they are given that we do not need to remove it from memory, but okay, which means this should not exist. This particular node should not exist, and value before and after the del node should remain intact, which means the order should be remain. If you are removing from the between or from very end or from starting, the order should remain exactly same as it is, which will be, I mean, we will not alter the order obviously. Okay, now number of nodes in the linked list should decrease by one. Obviously if you are removing out of n nodes one, then n minus one will remain. And apart from that, it is guaranteed that a value of del node, that a node with del node value will exist in the linked list. So it's not the case that there will be no case that you won't find it. Okay, you have to return minus one also. There will always be a value same as del node, which you will be able to delete. Cool. And now multiple nodes can have same value, but you have to remove only one. Fine. For example, one, we are given two nodes, 1 and 2, and del node is 1. We'll remove 1. Remaining will be 2, and that is our answer. Cool. We have to return the remaining one. We don't have to return it when it will just be implicit. So in example 2, we are given linked list of node 4s, 4 nodes, 10, 24, and 30, and a del node is 20. Del node is 20. Cool. So we just need to remove it, and the remaining will be 10, 20, and sorry, 10, 4, and 30. Okay, 10 from the beginning and 4 and 30 from the very end. Okay, we don't have to return anything. Also, the expected complexity is order of 1. Time complexity is order of 1. Okay, and space complexity is order of 1. The only thing that may confuse you is that there is no head node to start with, and that is why there is order of 1 complexity. You do not need to traverse or any such thing. You need to start, find a node, remove it, change the pointers. And space complexity is 0, you don't need to store it anywhere. So there will be two conditions: if the node will be last or not the last one. Okay, okay. Let's say if it is the last, which means there will be no next value after the delete node, del node. But cool. Now, if there is nothing after the del node, there's no next value, then del node will point to none. Del node has to point to none, even if it is last or not. If it is the last value, point it to the none and make it none, set node the none. Okay, which means we are effectively deleting it. Or if it's not the last, it is in the beginning or in the middle. Okay, in that case, we'll copy the data of the next node to the current node. How we'll do it? Del node dot data. Okay, in del node data will store the next of data, which is del node dot next data. We're storing the value of the next node of del node. Since it is not last, it has next value. We are copying the value of next node of del node, and we are storing it in the del node. Cool. At the end, we'll point the current node's next pointer to the node after the next, which means next will point to the next of next. How we'll do it? Let's see. Del node dot next. The next should point to next of next. Del node dot next dot next. So what I did over here is I will explain briefly. If it is the last element, make it none. If it's not the last, then store the value of next to this one and make next point to the next of next. That is it. Just simple, just effective. Order of one space complexity, order of one time complexity. Okay, 100% accuracy, and all the test cases passing in very less time taken. Okay, effective solution. I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.